Hello everybody. I hope you can hear us. Welcome to today's webinar. My name is Roman Shevets, and I'll be your host for today's webinar. So today we want to showcase Innovatrics ABIS for criminal investigation. This is the first in series of webinars introducing criminal investigation features of Innovatrics ABIS. And we will start today with the latent fingerprint identification in the crime scene investigation scenario. Rather than talking, we would like to show you live demos that require rather ambitious setup. Maybe you can see it in the small screen. And therefore, wish us luck that everything will go smoothly. And please be patient if we need more time to switch between different cameras and tools. While preparing for this webinar, I noticed that we have new names on the attendee list. So let me start with a very brief 2-minute introduction of Innovatrics company, focusing on law enforcement solutions and projects. Innovatrics is an independent provider of biometric solutions for governments and enterprises. We have been established in 2004, and Innovatrics has an in-house research and development center in Czech Republic, where we focus mainly on developing biometric algorithms for fingerprint, face, and iris recognition. Besides biometric algorithms, we also develop technologies like liveness and OCR, document data extraction, and also pose detection algorithms. Thanks to the great work of our R&D center, our algorithms, biometric algorithms, are ranking among the top in the independent NIST benchmarks, and especially our fingerprint algorithm is leading the benchmarks, and recently our iris algorithm was ranked and #1 in the world. Despite a stronger track record of Innovatrics ABIS for civil identification, with over 500 projects across 83 countries, we pride ourselves also of some very interesting projects for law enforcement. I wanted to list a few of those. We are powering the biggest criminal investigation ABIS in Southeast Asia with our 200 million records, featuring all 3 modalities: fingerprint, face, and iris. We supply local ABCs for several police offices in Brazil, in local states, and we delivered also very interesting project in West Africa, in Guinea, where we digitalized the police work. Besides the biometric identification of suspects, we also digitalized all the biometric registry, criminal biometric registry of the country. I also added a border control reference. This is the biggest border control project we currently supply, is in the Middle East, and it features 120 million records. We have a headquarters in Slovakia, in Central Europe. Our R&D center is in the Czech Republic. We have offices in Brazil, Singapore, and sales agencies in Taiwan, India, and Dubai. That is about the company. And now, quickly, before we start, a little housekeeping. The webinar will last 30 minutes. It will be divided in 2 parts. The first will be 30 minutes, the presentation, and then we will continue with Q&A session, which we will keep open until we answer all of your questions. To ask questions, please use the Zoom functionality. You will find this icon in the bottom of your screen. It's called Q&A. Just click it, ask questions, and we will address them in the Q&A session at the end. You don't need to take any notes, screenshots, anything like that. We will be sending you the recording to all of the attendees after this webinar. Without further ado, it is my pleasure to introduce the speakers for today, Michaela Frankova and Martin Marko. Michaela, stage is yours.
Hello, everyone. My name is Michaela Frankova, business consultant in forensics for ABIS team at Innovatrics. And this is?
And my name is Martin Marko, and I am a solution manager also in the ABIS team at Innovatrics. So what we will see today. Today, we will focus on the whole workflow on latent fingerprint collection and identification on a crime scene. So let's imagine this is our crime scene. We will show you how to collect those fingerprints, how to adjust them, make them better looking, and also how to identify them against the database. We will also show you how we can enroll new persons of interest into the database and show you the whole workflow from the beginning to successful identification.
Precisely. So let's have a look a little bit at the context, because this is a bit different from like a civil identification. So imagine we have a crime scene. With a crime scene, we need suspects, we need person of interest. So we will have those from witness statements, we can have those from CCTV cameras, or we can get them by other means. Or we have some people already enrolled in the database. Then we will continue exactly as Martin said with the collection of latent fingerprints, so that we will tell you a little bit more about it when we come to there, and we will finish off with the analysis. So Martin will tell you more about the databases and how they are created.
Yes, so typically almost all of our projects consist of migration of some legacy database. So typically this database can be a digital database. We will analyze it, check the qualities of the database, and then run some deduplication to check if no duplicates are inside of the legacy data, and migrate the database into new Innovatrics ABIS solution. Also, another option is to, as we did in the Guinea, for example, to digitize an old paper database. So we have also tools for enrollment from paper cards. We cut out the relevant fingerprints and faces from the papers and do this a little bit semi-automatic, I would say. But what we will show you today we will show you our enrollment. This would be typical use case when we already did the migration and we want to book or enroll new person of interest into the ABIS. So we will start with criminal enrollment, which is the most relevant for today's topic.
So, and Martin will be my, let's say, criminal for today. So he will be my volunteer. So we start with the criminal enrollment. The criminal enrollment contains several steps. So in this case, it would be a face capture. We will capture also irises, palms, slap fingers, and rolled fingers. As you can see on the left side, this is all customizable. We can customize it, and different countries have different requirements. So this is all possible. So let's start with the face capture. Lovely feature in our new enrollment is we can choose a camera which we need. At the moment, camera is pointing to my face, but obviously the person of interest is Martin. So I will want to choose different camera, which will show his face. Fantastic. Here you can see Martin against lineup wall with ECAO parameters. These parameters are basically, we want them all green, to say that in easy way. But when Martin is moving his head, rotating his head, we see the jaw angle is not perfect, or there is a nose shadow. There are different parameters, brightness, contrast, levels. Real, police station, this will be controlled environment, so there wouldn't be shading and it would look way better. At the moment, you can see on side of Martin there is a shade which is not perfect. And also with all enrollments, we need to really think about the skin tone and skin color of our suspects or person of interest, because if they have darker skin tone, we shouldn't use the white background. So we really need to think about this, but the operators are mostly aware of this and they will adjust the conditions for this. So I will ask Martin to look straight into the screen and we will capture his photos and we will continue on to profile capture. Fantastic. Here you can see we have rectangle, we can move it around, we can make it bigger and really, get that part of the, photo we need. We will crop it and we will continue with left half profile and capture it. Here is important to make sure both eyes are visible. We can crop it and we will continue on to the summary. If necessary, all the photos can be retaken or whole process can be restarted. So let's move on to irises. Irises are not really, in a real case scenario, but we really want to show it off. So I would ask Martin to look into the iris scanner. He is trying to make it difficult for the iris scanner and, squinting. But, the algorithm said this is sufficient. This picture is good enough. and it captured the irises with the auto capture. So next step would be palms.
Yes, but let's talk a little bit more about the irises.
Oh yeah.
So one very nice thing our R&D team achieved. So right now we are the #1 algorithm in the one-eye category of iris recognition, and we are the best on quite a landslide here. You can see, you can open this and read the whole NIST report, the latest IREX report. And also, this is our algorithm. This is not a lab condition algorithm. We have very small templates or so, and we are quite very fast. So this is production ready algorithm.
Fantastic. So let's move on to the palms. We are not using a palm scanner because they tend to be quite bulky. So we are just using small Kojak scanner, not really meant for palm capture, but it will do for this purpose. You can see it on the screen. So we will start with the right upper hand. So I ask you for your right hand. Operator would place the right hand onto the scanner, press it down in order to get nice quality palm print. You have to keep pressing until the auto capture happens. Let's try one more time.
Okay. Sometimes maybe if the hands are quite wet because I'm nervous or some other situation, you want to dry it off
and try one more time. Fantastic. We get a success notification, and then we can move on to the next part of the palm. So we will capture the bottom palm, and the last but not least, we will capture the writer's palm. Here, Martin, he is very cooperating, so he will continue on his own. And here we will show you, if necessary, we can skip parts of the palm. So let's say he has a plaster bandage on there, so we can skip the palm. And Martin will continue. And in the meantime, for example, where we can find palms, imagine a criminal or a burglar is looking through the window at his crime scene, he wants to rob someone, and he's looking through the window and scouting his crime scene. So he would leave those lovely writer palms on the window when looking through the window. So it's quite important for us to, capture those parts of the palm from the beginning. So next we will move on to the slap fingers.
Yes.
And again, I will show you, we will place right hand onto the scanner. And here, important thing is, the scanner should be ideally in the height of 112 to 117 centimeters. You don't want hand to be straight. So you want the hand to be straight. You don't want to strain it and have it like in different directions, because otherwise it wouldn't make good quality fingerprints. And these are the fingerprints we want the best quality, because the ones on the crime scene are usually partial and they are not that great. And another important thing is that operators should always wear gloves. And if suspect has very dry hands, we would use a soap and wash his hand and use a hand cream. Or if the ridges are not visible, we can use a ridge builder. There are different scenarios, but the operator should know what to do. So, and Martin will now show you how to enroll the slap fingers.
Okay, here you can see that our SDKs are checking if the right amount of fingers. So in this case, you can see the mock-up or how to, so it is very intuitive for the operator to understand. And you can also see that if I press only 3 fingers onto the slap scanner, the warning of too few fingers is placed there. Also, if I do not press hard enough, you can see that the quality of the fingerprint isn't good enough and it is highlighted in red. So if I do it properly, the algorithm checks, auto captures, and we collect the left slap, the right slap, and then.
And we can continue on to the left, but here, nice feature is we can turn into single mode. So we can take all the fingers individually. So Martin can show you, capture of left index. The UI is very nice here. It's very user-friendly, and the operator exactly knows what to do and how to place the fingers or the hand.
Yeah.
And we can move on to the next finger, or we can skip if necessary. In this case, you see, we can't capture it. So what we can do, we can skip it, and we cannot read a finger. There could be different external conditions why we can't do that.
The reasons are multiple. It can be, for example, plaster, bandage, or even missing fingers. Some people, accidents happened. Or also the reasons might be that the person is a manual worker and the ridges are worn out because of the working conditions, or for these reasons we could use the ridge builder, for example.
Exactly. We will try to capture the thumbs and move on to the summary. I can see Martin is really sweating because his fingerprints are very smudged. So we move on to the summary, and we can tell you a little bit more about, let's pick one fingerprint, but I'll still go back and show you, if necessary, we can capture from beginning, we can retake individual fingers. For example, those two, when we tried this an hour ago, it was all perfect. And now they are very smudged. And we can restart the whole process if necessary. But let's have a look at this finger and talk a little bit more about NIST parameters. So standardized NIST parameters, we are showing NFIQ1 score and also NFIQ score, which are quite important for a forensic fingerprint expert. And Martin will tell you more about.
We are also showing on the right side our proprietary scores. So we are showing placement score. The placement score tell us if the core of the print is present and the surrounding area. So this is most useful for the civil identification in order to have the fingers aligned the same way each time. And on the bottom, we are showing our proprietary fingerprint quality. So this quality tells us how good is this fingerprint for matching. If the qualities are bad, like in this scenario, we would do the redo the enrollment process. We can do enrollment process by the steps, so this will be on a 3-step process. And if, like for example, this one, prints are not that usable, we will redo the fingerprints.
Exactly, as we said, we really need good quality fingerprints for this.
But for criminal use cases, the best fingerprints to use are the rolled fingerprints.
Exactly, so we will show you how to take rolled fingerprints. You really want to be careful here and capture them properly, because at the crime scene, you will find different parts of the finger, partial latents. And for example, you will find only side of the finger or tip of the finger. So I will take Martin's right hand and we will start with the thumb. We will start with the thumb. So operator would hold the hand and then slowly roll the finger in order to get very nice fingerprint and cover, the largest area. This is not a great position for me to stand it. So Martin will continue and we will show you a little bit more. So this would be very nice. We continue with the middle finger.
The process we are using for the rolled fingerprints is the nail-to-nail process. So the ones which...
Exactly, that's the one we support. We are not supporting rock and roll. It's not as accurate, so we are supporting nail-to-nail.
And as Michaela said before, this is typically done by a police officer or an assistant who will help the person to enroll all of the prints. So just to skip and speed this process a little bit, we will look at the summary.
Well, first we will look at the summary, and right after that we can move on to the personal info.
So the personal information is also customizable as all of our processes, since we have the project deployed in multiple countries. Some countries have 2 names, some 3. Some countries have different codes and information they want to collect into the database. So for this reason, we can customize and accommodate all of the needs of our customers. Here we have a nice feature. We auto-filled some data just automatically for the demo purposes, and Michaela filled out my name into the ABIS.
Exactly. We move on to the overview. It's always important because sometimes you just have one try. You don't want to call the person of interest in to the police station multiple times. You want to do it first time the best. So you will check the photos, you will check the irises, and most importantly, you will check the quality of the fingerprints. So this is just for purposes of the webinar, but obviously we want to capture as good fingerprints as possible, rolled and the slab. And most importantly, do not forget to save your enrollment. Fantastic. And then you can see whether it was enrolled into the database. And again, check if there are any duplicates. You have to resolve the queues. And it's quite common that someone was enrolled several times.
Yes, exactly. We also accommodate these features and how to manage these biometric individuals inside of our ABIS. If you are interested in these workflow modules and how to process them, you can also look on the older webinars we did on this topic. But now let's move to the interesting part, then collection of the fingerprints in a scenario of crime scene. So let's imagine this is our crime scene. And
I'm not sure you can see now the whole screen and how I work with the Forenscope. So I need to turn on lights.
So Forenscope is a Turkish company. They are manufacturing many different devices for collection of evidence from crime scene. This is their 4K device. This is a latent fingerprint collection tablet. And the nice thing about the 4K is that it is contactless. They do not have to use any powders or chemicals. You still obviously can use them, but you can see this way, you can showcase fingerprints which are invisible on camera. You cannot see them, but with different uses of UV light, you can see the fingerprints. The typical use case here would be that a technician, forensic expert comes to the crime scene, and the crime scene is a whole room, so he has to know where to look.
And for this, we are using a fantastic function, which is like a wide search or sweep. Imagine you have a large window or a huge whiteboard like we have. I think you could see it behind us on the first slide. And we can just go with the Forenscope, which is really state-of-the-art device, and have a look in the whole room, at all the entry points. Forensic technician would normally know what are the points which are most touched, the table or maybe a fridge or toilet or, all the handles and light switches. So they would look at those places and just sweep it and then, pinpoint the fingerprints and then move the device closer. For this purpose, Martin.
Yeah.
I'm not sure if you can see on the camera, Martin will touch.
Yeah, so I will touch, for example, business card, just a simple touch. And this way on the camera, you wouldn't be able to see it, but let's imagine we want close up on those fingerprints. So what we have shown before was a large area sweep. Typically the forensic technician would then move closer to those prints. So we would find them on wall, on light switch, and the forensic technician would come closer, look at those prints, and then try to collect those invisible prints from the area of interest. So right now, Michaela is adjusting the focus and the brightness of the image and try to find whether
there are any usable fingerprints. For example, here I see lovely fingerprint. I will definitely adjust the ISO and contrast so you can see it way better. So you have to really play with it in order to get a really good visible fingerprint. So here, this is really lovely. You can see all the ridges.
For those who are looking at the screen, yes.
And most importantly, we will have to put a ruler there in order to capture the photo. It's important with all kinds of evidence to put a ruler in there. And now I'm searching for more fingerprints. There is another very lovely fingerprint, most likely Martin left behind, or maybe someone else. We will see that when we analyze them.
Yes. So maybe if you try to focus a little bit more or make maybe a little bit more visible. so our viewers can see it on the screen.
Okay. Give me a second.
You know, the compression over the video, sometimes it is a faint image. Yes, you can see them now. So those white ridges, this is the ridges which are left behind by the oils and sweat on your hands. And typically in a high stress scenario like a crime, people would leave quite a lot of it. You were able to see that high stress scenario also doing the webinar.
Exactly.
Yeah. So this way we are able to visualize it, zoom in on the image, and we want to capture the image also with the ruler. The reason for the ruler is we can have the DP of the scanner and we can use it, but with the camera can 10 centimeters from the surface, so different have there something physical for reference, and we will use this later in the post-processing.
Fantastic. So when we are happy, you know, with how the fingerprint look, you can capture it. I already captured a couple of fingerprints with really high quality camera, and so yeah, you should capture all the fingerprints, and then we can go back and you can see we have a library or so-called gallery with the different quality prints. You can always, you know, delete the prints from here or make new ones. You can also, you have different kind of, let's have a look, different kind of functionalities here. You can convert and share them. And in this case, we will share the fingerprints because we want to get them into our ABIS. So in this case, we will get them on a flash drive, but Martin will tell you a little bit more about what you can expect in the future.
Yes, so in the future, we are developing our cooperation with Forenscope, and we are developing ways of how we can improve this workflow and to upload those fingerprints directly to our ABIS without need to use like thumb drives or anything. But this is for the future. Let's focus on how can we use these fingerprints and how can we analyze them and try to identify who left those fingerprints behind.
Exactly. So we have a lovely investigation, criminal investigation module. So here we can create as many cases as we want. So just follow me. So we will add a case, which is in right top corner. We will name the case. Let's just name it webinar with today's date and time. And we can upload the data. We can upload different kinds of evidence because obviously crime scene is not just about fingerprints. It's about faces, DNA, ballistics, blood pattern analysis, etc. But for this use case, we will upload only fingerprints.
For the future, we are also planning another webinars for example, our video investigation tool. So you can look forward for that. And we will show you how to process video evidence from CCTVs. And also we can do SMT annotation searches. We can do DNA in the future. So we will keep you updated as the features keep coming and do another webinars. And we will slowly showcase you the whole suite of criminal investigation tools.
Exactly. So let's have a look at our fingerprints. We uploaded only 5 fingerprints. So it's important to look at the quality of the fingerprint. It's important to have a look whether they are, you know, sufficient for the analysis or not, if they are partial, if they even can be analyzed. Some fingerprints are thrown away straight away because, you know, the experts realize, you know, I wouldn't have enough minus points on this. So I'm not even you know, so for this purpose, it's already partial fingerprints. So, but yeah, for this purpose, it's perfect. So let's edit this fingerprint.
So for the editing, our fingerprint expert, Michaela, will first of all use the ruler. So she will normalize the image. So we have nice tool where you can select the distance either in centimeters or in inches based on which part of the world are using this algorithm. And she will normalize the image into the selected DPI. And then we know the image is consistent with the already enrolled fingerprints from the scanners in the database. Next, Michaela is cropping only the interesting area, so we don't need the ruler there anymore. We are now only interested in the area of the fingerprint. And now you can see nicely how the latent fingerprint looks, and we can move on to applying the mask. The mask can be applied automatically, or it can be done manually, for example, to avoid some complicated areas like the lettering. This mask is there to say the algorithm which area to focus on and which area to ignore. So right now, the algorithm will focus only on the whiteout area. And
We will cut by mask because this is easier for, investigating. You don't want to have like a background there, which will distract you. So we will like kind of like make the background white and continue with the analysis.
yes, now Michaela will adjust the image parameters like the brightness, contrast, and gamma. These are basic image manipulation tools, and they are useful for the operator to highlight the ridges the most. This will also help our algorithm, but most importantly, this will help the operator to see those ridges and therefore minutia points. Now, Michaela will invert the image. This tool is helpful when we want to have the ridges black on white, not white on black.
Exactly.
And then we will do a histogram normalization. Histogram normalization is automatically bringing out most important features. So it will bring out the ridges and reduce the background. And the next step is minutia detection. Algorithm only on this cutout area of the fingerprint will detect minutia, so either bifurcation or endings. Another feature which our fingerprint use right now is deleting of erroneous minutia points. Some minutia points, mostly on lower quality fingerprints, or if the mask wasn't applied properly, can be erroneously placed, or also if we have a lower quality fingerprint, the fingerprint expert can place also minutia points manually. So if the quality of the image is very bad, our algorithm may struggle a little bit. So the expert can place and decide if it's a bifurcation or ending, and also align the angle. When the fingerprint expert is happy with all the minutia point detection and she knows that this is okay, then we will save the image into our gallery, and this saves and keeps tracks of all the changes, so it is kept the history there.
Exactly. So the history is kept there. So if we would go back, we can see exactly what changes did I do to this particular image. And now we will move, before we move on to identify, Martin will explain a little bit more about the settings over here.
Yes, so the identification can be performed with multiple settings. We can adjust the threshold, we can adjust the speed and rotation. For our purposes, the speed and rotation does not really matter. We want to keep it as slow as possible, but the threshold defines if we what kind of score does have to the matching fingerprints have in order to show in our comparison in the future. So this is quite a low score, but we have very few people inside of our database, and we will see that we have quite a lovely match with my own fingerprints on multiple occasions. You can see there, but on all of them, you can see there is quite a lot of matching prints on different jurisdictions. Different amount of minutia points have to be matching. Multiple matches are shown also because we have multiple prints per each enrollment. So here we can see there is a rolled print which matched, and here we can see there is from the slab scanner.
Exactly. Here you can also see minutia points, like 46 out of 59 were same, but that's because we have very good quality prints.
Yes.
So now
also the score is on the scale 0 to 100. So 85 is a very nice score. This would be a nice score even for like civil identification, which showcases the quality of the imaging from the Forenscope and also the quality of the print for this mock scenario.
So here we have a look at the different minutia points. the investigator will have to, or the expert will have to look at each one of them, and conclude whether this is a match, no match, or it's inconclusive. So it's very important to have a look at each one of them and have a look whether the algorithm plays them correctly.
Also, one nice feature is, as you can see, the side-by-side view can be aligned based on individual minutia point. It will realign and adjust the rotation and also the zoom. And then when the operator is moving, zooming out, then the images keep the same orientation. So we can check if it's the same.
So, and when we are confident enough these two prints are matching, we can mark this as a hit. So we can mark it as a hit. And after it was marked as a hit and we go back to the case, we can see that this particular fingerprint was identified. So it was identified and the hit was Martin Marco. He had several duplicates in the database. And when we click on more info, we can see again both of the fingerprints side by side. This information can be exported if necessary. Here we can see all the probe coordinates, all the minutia points, exactly, side by side, and their placement.
So this means I committed the crime.
No, it doesn't mean you committed the crime. It means Martin Marco was at the crime scene at certain time. We don't know whether he committed the crime or not. We just say the fingerprint basically places him at the scene of crime. So
I will have to find a good alibi.
Exactly. So he will need to have a good alibi. And also we need to have a look at more evidence. An investigator will have to really analyze it thoroughly in order to, come to a conclusion.
So next time, more evidence?
Exactly, maybe DNA or, video investigation. We will surprise you, definitely.
So let's have a time for your questions. Roman, do you have any questions from the audience?
Okay, guys, so that was intense. Yes, we do. I will ask the question, then I will try to change the screen to the camera so
okay,
you can see us. Okay, we have a question from Rudolf, and he's asking us which version of the NFIQ2 algorithm does your solution use? Currently, we are on 2.2.
Okay, so this would be very good. The right, since we are use different versions of the algorithm on of our deployment. So the best we had a deployment and you would require specific version of the NFIQ2 algorithm, then we will be able to provide it. So it depends on your needs, basically. We can accommodate
Okay.
whatever.
We have another question from Sarah Bora. Is the matching scale and rotation invariant?
Matching scale and rotation. If we are talking about the rotation in the identification, if Michaela, if you can go back at the investigation, then the settings of the identification, if you can.
Okay, settings.
This one.
Yeah, here we are.
So here we can see that you can adjust the rotation. At the criminal investigation, typically you would keep it at 180. So this means it can be rotated whichever way. This slows the algorithm a little bit down, but for the criminal investigation, you are not in a hurry. So if you have a civil use case where you have a slab scanner and you know that the rotation is plus or minus 20 or 40 degrees, then you can adjust and tighten the rotation a little bit and then make it the matching speed a little bit faster. But here, when we set it at 180, the fingerprints can be rotated whichever way.
And it's very important because we really want to avoid miscarriages of justice. Fingerprints are oftentimes, analyzed incorrectly. And we really believe our algorithm is really the best. So the time plays no role here.
Yes. Do we have another question?
Yes, we do. Another question is from Richard. And he's asking, can you import or export ANSI/NIST templates? If so, which implementation?
Okay, we can import and export NIST. We can import and export. Are you asking about ANSI and ISO templates of the fingerprints from the database? Yes,
Probably.
Yeah, okay. So we have a special SDKs for this purpose, and we can generate ANSI templates, ISO templates, also the compact ones, and ILO templates. So multitudes of the standardized templates we can create and export.
Okay, let's continue with the questions. They are keep on pouring in. The other question is from Najim Alao, and the question is, what's the minimum camera resolution for capturing?
I presume this is for capturing of faces. So
you can specify a question.
So for the faces here, we are using higher quality webcam. So this is the Logitech Brio, which is, I presume, 4K.
Yeah.
But 1080p would be probably sufficient. Also, in our enrollment, when we are using the facial enrollment, so the part of the enrollment when we use faces, we check for minimum eye distance in pixels. So when you set it up, you can select. I think the minimum is like 40 or 50 pixels between the pupils. So that's not very huge, the resolution. We can work with quite small resolution for the faces, but the better, the larger the better. And for the latent fingerprints, for this, we are using a 4K device. Forenscope is also developing a better resolutions one. Many police departments are using DSLR cameras with powders. We can also use the powder images in our investigation station. So yeah, many of them have 20, 50 megapixels. So the most important part for the fingerprints is you have to have the ridges visible. So for the cameras, it also depends on the distance and the quality of the prints.
It depends on the quality of the prints, but we pour the data into our database and train the algorithm on different kinds of prints. They were on different kinds of surfaces, and they were captured with using different kinds of powdered or chemical methods, so even fluorescent methods. So it really doesn't matter for the algorithm, what kind of method was used.
Yes.
Okay, let's continue with the question from Priscilla Abide. And the question is, can an already existing database be used to run a search using your solution?
So part of our solution is to migrate the data inside of our database. So this is what we typically do. We move the data inside of our database and then store them and perform the identification against them. The most important reason for this is we are using internally, in order to have the best matching performance and have the highest quality match, we use our proprietary templates, and we have to generate them and then keep them and store them. So if you have a legacy database and you have the pictures, we can migrate them inside of our database. But if you would want to use some standardized NIST or ISO formats, they do not have all the information that our proprietary templates have. So therefore, we always want to migrate the data inside of our database to give you the best performance possible.
Thank you. Let's continue with the question from Galip Emre. During a rolled fingerprint image capture, if the finger slips on the scanning surface or rolled more than once, is there a compensation for possible smears due to the slipped finger?
Okay, so for the enrollment process, for the criminal enrollment, when we use the rolled fingerprints, the involvement of a trained assistant, typically a police officer, is very important. So when we are calculating some qualities ourselves, and we can check them, but the trained eye of a professional is always the best. So when the enrollment process is finished, we have the summary, and the police officer can look and see, okay, this is matched, and we want to retake only this print, for example.
Exactly. It's very important to, as I mentioned, have very good quality fingerprints from the start. So if you have a smear there, or it's smudged and your fingertips, slips, it will even give you an error, like, there was a slipping of the fingerprint. So it will give you error that the fingerprint is not sufficient for the auto capture, and you can restart the process. That's why it's important to have the restart and retake functions, ready, implemented in order to retake really good fingerprint.
Thank you. Let's continue with another question from Richard. He's asking, is the ABIS solution desktop, server, and or cloud-based?
So ABIS solution can be deployed on multiple types of hardware. Typically, it is a server, but our minimal requirements are like 32 gigs of RAM and at least 4 CPU cores dedicated to the ABIS. So if it could be possible to install it on machine like our laptops here, but typically we installed it on a large cluster. There are many benefits for this because we can provide the high availability functionality, and also when we have a project like the Middle Eastern border control, where we have like 100,000 registrations a day, then we have to be quite fast and large scale. So we can install it on any Linux machine, but most Linux platforms. Typically we support Red Hat Enterprise Linux and some other industry standard Linux distributions. And on them, we can run it as a virtual machine inside. As I mentioned, those minimal requirements. If we have it also, we have some deployments in cloud. So this typically for testing purposes and ease of use. The machine which we are running right now, it's in the AWS cloud. So we can accommodate multitudes of requirements.
Thank you, Martin. Now we have a question from Stembile, I hope I read it right, about the Forenscope machine. So maybe we can answer that as well if we know the answer. Which substrate or material can your camera capture fingerprints? Is that the paper or plastic?
Okay, so the camera can capture fingerprints from different kind of surfaces, and basically it's all surfaces. So if you are not using powders or chemical methods, it can be glass, plastic, paper, it can be a metal, but this camera is really good because it doesn't capture only fingerprints, it can capture also different traces such as bodily fluids, saliva, semen, etc. And it can even capture gunshot residue. So it's really multi-spectral.
Thank you. Now we have a question with a like from Leanne. On the 10 print enrollment, is there a verification sequencing happening from 10 print rolled to flats to palm print?
Okay, we call this local deduplication. So we check if the prints aren't the same. For example, if I place my right slab and on the required left slab, I place the right slab again. Or for example, switch the fingers between the rod and slab, then we check against each other and we will say, okay, we have a local duplicate. So you already placed this finger. So we check if the finger, as possible, we check if the fingers are unique and on corresponding positions. You can make an error. It is possible because sometimes our algorithm will not know how do you place it. But for example, on the slab scanner, we check for the arch of the finger so we can distinguish if this is a left hand or a right hand. So we will also check this and make a warning for the operator if something is amiss.
Yeah, and does this happen also with the 10 print cards? Like when you segment them and you enroll them into the system? Because I think Leon was asking about paper enrollment. So is it the same procedure, Martin?
We can do it. Yes, it is possible to do this and check also on the paper cards if everything is matching and on the correct positions.
Thank you. Let's continue with a question from Siva. I hope you're not tired yet. Questions coming on. So fingerprint capture, we can use Innovatrics SDK or need to use vendor SDK?
So the SDKs, if you are building, so here we are showcasing our enrollment station, our bioscriber, which is running on the web. We also have SDKs for enrollment. And with these SDKs, you can build your own enrollment station if you want some Android station or desktop application on Windows. You can, with the help of our SDKs, you can build an enrollment station. And this helps you, for example, run the extractions locally and not bother the server. Or, for example, also use the segmentation SDK, which I was talking before. So you can, with this SDK, you can check if the SLAP is matching. So, but you can also use our solution. And for the device manufacturers SDKs, so if you want to build your own enrollment station, we are hardware agnostic in our SDKs. So we are working with images, and you have to get those images from those devices. So if you want to build your own enrollment station and implement your own devices, you will have to use also the SDKs from the manufacturers.
Okay, let's proceed with a question from Jose, but before, I have a question from Rizwan, and I don't understand it, so maybe if you can specify better in another question. You are asking any limitation of images. I don't know if you know how to answer these questions.
No, we would need a little bit more specifics
Okay.
for that.
So let's proceed with the question from Jose Angel. There are solutions to enroll fingerprints with mobile phones. Do fingerprints enrolled with these devices have an effect on the accuracy of the results?
The short answer is yes, they do, but we can use them. So it's always best, since as you can imagine, if you place your fingers on the scanner, you push a little bit and you flatten the prints. If you only take a picture with a specialized application and a contactless scanner, then the finger isn't pressed against the surface, so it looks a little bit different. We can match between them, but the scores, it is always best if you are using, for example, a civil application, to have the same type of scanner. So if you are using contact scanners, then compare contact with contact. If you are using contactless, then use contactless all the time, and then it won't be affected. But if you are mixing and matching between them, it will work, but there is a little bit of a hit on the matching performance.
Okay, now this is a very interesting question from Galip. If the latent image is overlapped with another latent fingerprint and or writings or pictures on the capture surface, can we separate overlapped latent images?
Okay, very good questions. Yeah, we do have a rich separation tool, which I believe we already showed in one webinar. My colleagues Alejandro and Josef showed this, but we do definitely have a rich separation. So imagine two latent fingerprints overlapping each other. To some extent, we can definitely separate the ridges to see them. And the same with the writing, but you always need a human factor in there. You know, someone who will do the work, someone who will have a look. If it's a fingerprint on writing or in a money bill, you always need someone to, check the minutia points, by hand.
Perfect. Thank you. Let's continue with the question from Richard. What vendor capture devices are compatible for fingerprint, probably capture, e.g. integrated biometrics, genetic, HID?
We used some scanners from all of those companies already. So it depends. You can send us a request and we can implement it and talk in detail which device would you need. But all of those companies, here we have integrated IB Kozak, we had also the smaller IB scanners, we had also from Genetrix some scanners. So we can work with them. We did in the past, so it depends on the type.
Yeah, on the use case, and we can basically integrate any scanner which client requires.
Okay, let's proceed with another question from Priscilla. If it's saved in a cloud-based format, who has access to the backend of this saved data?
It depends on you, how you set up your architecture. So it is always best to have it in a closed system behind the firewall and to do all the precautions you can have and to make sure that no unauthorized persons will access this environment. But also we, for example, for the editing, we have a role management system. So only allowed and authorized person can log into the system. And we can also have different roles and different rights for each roles. So, and this can be also customized for each of the projects. So we also have some workflow management where we can have some administrators which only checks for duplicities, for example, and we can have another role for latent fingerprint modification, and we keep track in the history, and in the modification we also keep track who created this case, who did the changes. So we have a basic role management and secure this access to the ABIS, and also it is best to do precautions and keep the servers closed up.
Exactly. I would totally agree, because this is different from the civil databases. With the criminal databases, you really need loads of precautions in order to keep it safe. There are loads of ethical issues, and you don't want anyone else looking at your data, and there are miscarriages of justice. Someone can look into your cases and then try to affect them in not really nice ways. So it's very important, and we can always advise customers on how to do this.
Okay, let's proceed with the question from Muji. Is there any training specifically for latent fingerprints, like how to collect, how to convert to digital properly, so it's easy to match, etc.?
Oh, well, I'm the forensic expert at Innovatrics, but we do not offer such trainings. We would love to do more webinars if we can in the future, definitely. But at the moment, I'm just advising my colleagues and our clients on how to do this. So if you're a client, there is definitely possibility of a training, on collection or digital capture of the latent fingerprints.
But typically there is a college education for this.
Yeah, of course. Yeah, there is a college education, but there are different kind of companies doing the extra trainings. But you can really look this up online.
All right. Looks like last question from Jose. Do you consider that mobile solutions are mature enough to be used as enrollment mechanisms? This considering the diversity of qualities in cameras that exist today.
Okay. One device which we did not bring here is our Android enrollment stations. So we have multiple different enrollment stations which we are already custom built on Android platforms. We have one which is like the integrated all together from, if you help me out, the small one.
We do have.
But we can also build a custom, so you can have any Android tablet and connect a scanner to it and use the camera for enrollment with pictures. And we already have this implemented on, I think, the Asian countries. The police department walk around with those tablets and use them for identification.
They are handheld devices, and they are perfect for instant verification. And actually, it's idea for the next webinar. We would like to show off instant verification together with instant identification using these very smart, devices which can
Yes.
be used in the field.
You can look up its Copernic device. So we have already our application on there, and we have implemented an enrollment station with this device. So if you are interested in this type of small mobile handheld devices, and basically we can implement and we can help you create your enrollment station on whatever hardware you need. So you can have it on a Windows device, you can have it on Android device, or whichever way you need.
Okay, and this is the last one, probably. Is it possible to segment the stored fingerprints identities to restrict search access by end user department or other attribute?
Sorry?
Could you repeat?
If it's possible to segment the stored fingerprints / identities
Okay.
to restrict search access by the end user or department or other attribute.
Yes, so for the roles in the investigation, you can customize it. So you can have some people who will only have like access to the applicant overview. And for example, some police officers will be only allowed to do the enrollment process and look at the applicant overview. And another will be allowed also, for example, these will be the fingerprint experts, and they will have also right to access the criminal investigation tools and do the identifications.
Yeah, but you can segment this, even though you called it segment, but you can also divide this. For example, you have the applicant screen, you have your database. You can even divide this database into separate galleries, and each gallery can be, accessible by a different law enforcement unit or different law enforcement person.
All right, perfect. I think that concludes the Q&A session. There is one more answer I can do or question I can answer. Yes, we'll be sharing the recording of this session. Don't worry, you will receive an email today or tomorrow. Okay, so thank you very much. Thank you, Michaela. Thank you, Martin.
Thank you, and hope you enjoyed this webinar and learned how to do latent fingerprint identification with our solution.
Yeah, and we are looking forward to the next time, and we will definitely make some surprise webinars.
Yes, as said at the beginning, this was the first in series of the webinars that will be showcasing the features for criminal investigation of Innovatrics ABIS. So stay tuned and see you next time. Have a nice day.
Bye.
Bye-bye.